All right, so multiplying radical expressions, and then in a little bit we'll talk about dividing and rationalizing the denominator. But first, multiplying. Okay, so whenever we have two radical expressions separate from each other, if they're both under the radical, they can be multiplied together. So root 3 times root 6 would be the same as square root of 3 times 6, which is 18, right? Now, can 18 be simplified? Is there a perfect square that goes into 18? 9 does, yeah. So we're going to break that into 9 times 2, and so we end up getting 3 root 2. So on your whiteboards, I'll have you guys do this one. Square root of 8 times the square root of 6. Okay, so the answer was 4 root 3. All right. You also might have a situation where you've got a radical that's being squared. So if it helps you to rewrite it as times itself, you can do that. You can write that as 5 root 3 times 5 root 3. And so I can take the numbers that are outside the radical and multiply those together, and take the ones that are under the radical and multiply them together. And so I have 25. And what's the square root of 3 times the square root of 3? It's just 3, right? Because it comes out to 9, and that's square root of 3. All right, and so then that would equal 75. So on your whiteboards, I'm going to have you guys do this one. All right, so you should have gotten 20. Because 2 times 2 is 4. Root 5 times root 5 just comes out to 5. 4 times 5 is 20. All right, so sometimes you're going to have an example like this. It's still, you're just going to keep the stuff that's on the outside, multiply what's on the inside. Although, well, I'll just go ahead and do it that way. All right, so I've got the 2 on the outside, and then 8x times 4x gives me 32x squared. So what perfect square goes into 32? 4, there's a bigger one. 16, right? It's 16 times 2. So I can break that down into 2 times the square root of 16 times the square root of 2 and times the square root of x squared. So the 16 and the x squared, I can take those square roots. So I get 2 times 4 times x times root 2. And so that comes out to 8x root 2. Any questions on that? Okay. All right, so on your whiteboards, I want you to do 3 times the square root of 3y times the square root of 12y. So on this one, when you multiply them, you get 3 times the square root of 36y squared, and both of those are perfect squares. What's the square root of 36? 6, and the square root of y squared? Y. So it just comes out to 18y. All right, here's another example for your notes. Now we're going to use the distributive property. So I'm going to take root 2 times 5 and root 2 times root 12. So the root 2 times 5, the 5 is on the outside, there's not a radical over it, then the 2 stays under the radical, so I just write it as 5 root 2. But the 2 and the 12 are both under the radical, so I multiply them together and I get 24. Is there a perfect square that goes into 24? 4 goes into it, right? Okay, and so then that means I have 5 root 2 plus 2 root 6. And that can't be simplified any further, so that's your answer. Any questions? All right, I'm going to have you guys do this one on your whiteboards. All right, so you should have gotten 3 minus the square root of 15. Got one more of these I want you guys to do on your whiteboards. I'm going to have you do this one on your whiteboards also. Okay, so when you distributed, you should have gotten the square root of 50 plus 4 times the square root of 15. And then the square root of 50 simplifies to 5 root 2. So 5 root 2 plus 4 root 15. All right, so now we're going to talk about dividing. Oh, no, we're not. We're going to talk about multiplying sums and differences. Okay, so it's still like you did with binomials where you just distribute. So I've got the 4 times the 3, that gives me 12. 4 times root 5, or negative root 5, I get negative 4 root 5. Then 3 times root 5, I get positive 3 root 5. And then root 5 times negative root 5, I get negative root 25, right? What is the square root of 25? 5. So I'm going to go ahead and just write it as a 5 there. Okay, so now, instead of just the middle terms being able to be combined, we actually have numbers on either end that we can also combine. I've got a 12 and a negative 5. So what's 12 minus 5? 7. And then I have a negative 4 root 5 and a positive 3 root 5. So that comes out to just negative root 5. So the final answer ends up being 7 minus root 5. Okay, on your whiteboards, I'm going to have you guys do this one. Okay, so when you distributed, you would have gotten 4 root 3 plus 20 minus 3 minus 5 root 3. So if I combine my numbers, 20 minus 3 is 17. Then combine my radicals, I get minus root 3. Okay, sometimes you're going to have a sum and difference pattern where the numbers are the same. Just like when we used to have, x minus 3 times x plus 3. It's a similar thing here. Your middle terms are going to drop out. So I'll just show you what happens when we do it. If we do 5 times 5, we get 25. 5 times negative root 2, I get negative 5 root 2. Here I get a positive 5 root 2. And then what's root 2 times root 2? It's just 2, right? And so we get minus 2. So these cancel out, and I'm just left with 23. So when the terms are the same and all that's different is a plus or a minus, you actually end up just getting a number without any radical expression. Okay? All right, I want to make sure we have time for all of this. So we're going to talk about rationalizing the denominator. So when what I mean is, well, you guys know what a rational number is, right? Okay. I can't have an irrational number like the square root of 2. That's irrational. It's a decimal that goes infinitely and never repeats. I cannot have square roots in the bottom of a fraction. They have to be rational numbers on the bottom. So what we do is we figure out, okay, well, what can I multiply it by to make it a perfect square? So 2 times 2 would make it a perfect square, right? So I just multiply by root 2 over root 2. If you multiply the top and bottom, you're not changing the value. That's just a form of 1, right? Because root 2 divided by root 2 would just be 1. So then you just multiply straight across. 7 and 2 are both under the radical, so we have the square root of 14. And on the bottom, we just have 2. Because the square root of 4 is 2, right? So on your whiteboards, I want you guys to do the square root of 5 over the square root of 3 and rationalize the denominator. Okay, so you multiplied by root 3 over root 3, and you got root 15 over 3. So you could always just multiply by whatever's on the bottom, and it'll work. But sometimes you don't have to use numbers that big to make it work out. Because if I did 8, now I'm going to have 64 on the bottom and 40 on top, and it's going to be bigger numbers than I really have to work with. Can you think of something I could multiply 8 by and have it come out to a perfect square? I can multiply it by 2, yeah, because 2 times 8 is 16. Now, what about that x? So I need that to be a perfect square also. So I need another x. So I'm going to multiply the top and the bottom by 2x over 2x. That is the square root of 2x over the square root of 2x. So if you multiply across, I get the square root of 10x over the square root of 16x squared. And so we just take the square root of the 16 and the x squared on the bottom. I still have the radical on top, square root of 10x, but on the bottom I just have 4x. And now my denominator is a rational number. Okay, so on your whiteboards, the square root of 7 over the square root of 12x. Okay, so we got the square root of 21x over 6x. How come I can't cross those x's out? Because one's under the radical and one is not. So you can't reduce those x's like that. The x's, when they're not both under the radical, you can't reduce it, okay? Alrighty, that's it for today.